All right, last video for topic 6. We're going to apply some of those properties we've been working with of our special parallelograms. First, the question is, what value for x makes this parallelogram a rhombus? So we go into it assuming we have a rhombus. A rhombus has 4 congruent sides. A rhombus has diagonals that bisect each other. A rhombus will have diagonals that are angle bisectors. And a rhombus will also have diagonals that are perpendicular. That's the first thing that's going to help us out. The diagonals of a rhombus are perpendicular. So if we look at our picture, we have perpendicular diagonals. So we have right angles. Well, that's also a right triangle right there, isn't it? We've got this triangle. We know that this is 90 degrees. We know that this angle is 36, and the angle we're looking for is that third angle in this right triangle. So to find x, all we have to do is take 180, subtract out the 90, and subtract out the 36, and we will get the measure of angle x to be 54 degrees. So what value for x makes this parallelogram a rhombus? When x is 54 degrees, this will be a rhombus. All right, so if the measure of angle 1 equals 36 degrees and the measure of angle 2 equals 54 degrees, is PQRS a rhombus, square, rectangle, or none of those? Maybe we don't have the right information to say that it's any of those. Okay, so a couple ways we can approach this. Well, why don't we start by maybe filling in, let me make this a little bit bigger, just so I can, there we go. I can write in those angle measures a little better. So we know that angle 1 is 36 degrees. We know that angle 2 is 54 degrees. So some other things we can get from that, because this is a parallelogram, opposite sides are parallel, right? So these opposite sides are parallel. If I'm going to draw on this, I'll end up erasing it so it's not in our way, but if I trace over the parallel lines and then I connect them, this is a transversal that's connecting those two parallel lines, you're going to have alternate interior angles that will be congruent. So this angle right here is an alternate interior angle, and this angle right here is an alternate interior angle. So those angles are going to be congruent. So if this is 36, this angle up here is 36. So I'm going to get rid of that green, I think, or not. There we go. And I'm going to go ahead and write in 36 degrees. Now we have these parallel lines. I'm just going to highlight in green. I can, nope, not those. Sorry, I want to keep looking at these parallel lines, highlighted in green. What we looked at before was this transversal connecting them. Well, we have another transversal that we could highlight over here. Here's another transversal connecting our parallel lines. This 54 degrees is an alternate interior angle for this pair of parallel lines with this transversal. So that makes this the alternate interior angle that will be congruent to it. So if this angle 2 is 54, this angle right here will also be 54. So I'm going to get rid of the green outline and then we'll write in 54 degrees right there. All right, so 54 degrees. So here's how this helps us. We have a triangle, and we have essentially the same triangle over here, right? Where we have two angles of 36 and 54, two angles of 36 and 54. Can we get this missing angle of each triangle? Well, if we take the 180 degrees from the triangle, subtract out the 54, subtract out the 36, we actually get 90 degrees. So you would do the same math with both triangles, but what we're figuring out is that we have 90 degrees where your diagonals meet. So that means that the diagonals are perpendicular. So when your diagonals are perpendicular, we can get rid of a rectangle. A rectangle does not have perpendicular diagonals. So we're trying to figure out, could this be a rhombus or a square? The difference between a rhombus and a square is that a square will have 4 right angles and a rhombus will not. And those are angles at the vertices, not in the middle where your diagonals meet. So we also know that the diagonal will be an angle bisector. So if this is 36, this is 36. If we have a 36 over here at R, we have a 36 right there. That's enough information. 36 plus 36, this angle P is 72 degrees. It's not a right angle. So we do not have right angles in the parallelogram. So it's not a square, which makes this a rhombus.